In this video, we're going to be talking about basic functions and their graphs. So these are functions that you're going to see quite a bit, and we call them basic functions or maybe even parent functions. And then we're going to look at how their graphs are defined, and then we're going to do this for quite a few of them, and this will be a good reference for when you see these functions in other forms in the future. So maybe a transformation of these functions is what's going to come up in the future. So starting off, example of a constant function. So this is one example because there's infinitely many constant functions. This just says f of x is 4. In other words, y is 4. So for any x value that you input, your y value or output is 4. So if I go up to my 4 on my y-axis here, then when x is 0, y is 4. When x is 1, y is 4. When x is negative 3, y is 4, and so on. So every point on this graph would be on this horizontal line. Okay, and so a constant function has a graph that is a horizontal line. The domain, remember domain meant input, so the inputs that go into this function, well, x can be anything, and you can tell from the graph it goes all the way to the left and all the way to the right. X can be any numbers, so it can go from negative infinity until positive infinity. All x values work. The range is what comes out, it's the y values, and so the only y value that ever came out of this function was 4. So this goes from 4 to 4, or the way we can write it is that it's just the set containing 4. 4 is the only output. So it's the only thing in the range. Then the intercepts. Intercepts are when you touch the y or x axis. And this graph only hits the y axis and right at that point. So x is 0 at this point. And then the y value is of course 4. So that is the intercept. In general, I'll just kind of generalize this for you real quick. If you had the constant for any other number for y, we'll just call it c, then your intercept would be 0, c. Next example of a linear function. So let me generalize this for you real quick. In general, a linear function is y equals, or f of x equals, mx plus b, where m is the slope. And so there's a really fast way to graph this. If you notice that this is in slope-intercept form, this number in the back goes right into the y-intercept. So if I plug in 0 for x, this is going to equal 3. So 0, 3 is a point on this graph. And then from that point, this number that's multiplying x is what we call the slope. M represents the slope. So our y-intercept, let me put it over here just so we have it. Our y-intercept is 0, b. In this particular example, it's 0, 3. And then our slope here is negative 2/5. So slope means that we rise and run, or in this case it's because it's negative, we're going to drop. So slope, we're going to rise if it's positive and then run. But in our case, we'll say we'll drop 2 and run 5. So from this point, we're going to drop 2, so down 1, 2, and we're going to run 5 to the right. You always run right on the graph. So 1, 2, 3, 4, 5. So drop 1, 2, and run 1, 2, 3, 4, 5. Okay, and then 2 points is perfectly enough to draw a line. And so we draw a straight line through those points, and that is this linear function. Okay. And the domain on any linear function, notice this graph would go all the way to the left and all the way to the right. So the domain is all real numbers, or from negative infinity until positive infinity. You can plug in any x value here. The range, now take a look at the range. The range is the output. So if you look at it visually, this graph will eventually go up toward infinity and down toward negative infinity. It will eventually cover the entire y-axis, or y values from the y-axis. So the range is also all real numbers from negative infinity to infinity. And now let's move on to the identity function. So the identity function is when f of x equals x. In other words, y equals x. So let's just plug in a handful of values. When you have a table, you should try different types of values. So I'm going to pick negatives and positives. So I'm going to say -2, -1, 0, 1, and 2. And if I plug those into my function, f of -2, well, the output is the same thing you plug in. The output is x. So -2. This just says y equals x. So when I plug in -1, my output is -1, and so on. And so when we plot these points, we have -2 for x, comma, -2 for y, -1, comma, -1, 0, 0, 1, comma, 1, and 2, comma, 2. And if I plugged in more points, because this is only 5 points, but if I plugged in more, they would all be on this line right here. And so this is the identity function, this diagonal line, perfectly diagonally through the middle here, through the origin. The domain again on this one is going to be all real numbers, because you can plug in any x value you want, and you're going to get a real number that comes out of the function. And then the range is also going to be all real numbers from negative infinity to infinity, because this graph will eventually have outputs of all the y values, because all real numbers will come out of this function. And then the intercepts, on this one, there's actually only one, so both the x and the y intercepts is the same point. It's 0, 0, because we hit the x-axis at this point, and we also hit the y-axis at that point. I actually should go back one example for our linear function back here. We should probably mention the x-intercept. I didn't mention it here, so let's backtrack just a tad. The x-intercept, it's not really showing up very well on the graph, so let me do it algebraically. It would be when we have a y value of 0, because we wouldn't be any higher than the x-axis or lower on our graph, so y would be 0. So you would just solve this equation saying that y is 0, or f of x is 0. So we'll do that real quick off to the side here. When y is 0, or f of x is 0, we have -2/5 x plus 3. So we'll just do a little bit of algebra and solve for x. I'm going to subtract 3 from both sides. So we have -3 equals -2/5 x. And then I would divide by -2/5, but because it's a fraction, we would flip it and multiply, and times by -5 halves, -5/2. And so that looks like x, I'm kind of running out of room here, but x is going to be -3 times the reciprocal of -2/5, so times -5 halves. And so x would be, and I'll just put it right into my coordinate now, so my x-intercept, the x value is going to be 15 halves, or 7.5, 15 halves, comma, 0. So over here at about 7.5, we would be touching the x-axis. That would be the x-intercept. Alright, let's go down to quadratic functions. So when you hear the word quadratic, it means that there's an exponent of 2 on x. So the highest power on your variable is the second power. That's the quadratic function. So f of x equals x squared. So I'm going to pick the same 5 x values I picked on the last one, and let's plug those in. So -2 squared, be careful because you would plug in -2 to include the minus sign in for x, and whenever you substitute you should use parentheses. So it really looks like -2 quantity squared, so that gives us a positive 4. -1 quantity squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And so let's plot those points. So -2, comma, positive 4, -1, comma, 1, 0, comma, 0, 1, comma, 1, and 2, comma, 4. And if you're not familiar with this graph, be careful how you draw it. It's not V-shaped, it's actually rounded. This is a parabola. And so this one looks like this. This is called a parabola, if you've never seen this one before. And so, let me just write that here. The shape of a quadratic function, any quadratic function, is going to give you a parabola. Sometimes they're wider, they're thinner, they're flipped down, they're shifted over, but in general this is the shape. And so the domain, any x number you want to plug in, you can. You will get a real number out. So negative infinity to infinity. Now the difference on this one with the range than the other ones is the range is not all real numbers. No matter what we plug in, if it's negative or positive, when we square it, it's going to turn positive. So this graph is never going to come down here to the bottom half of this grid. So it's never going to have a negative y value. So the lowest the graph will ever be is 0. And then it's going to keep going up toward infinity. And so you have a point at 0. So whenever you have a point there that you can equal, that's going to get a bracket. But as we go up to infinity, we can't equal infinity. You can never equal infinity. It's just more of a concept of something very large. And so you put a parenthesis there, saying you get close to it, but you don't ever actually equal it. And then on this one, the intercepts are the same as the last example. Both the x and the y intercept is 0, 0. We touch the y-axis and the x-axis at the same point, 0, 0. All right, last one for this page, cubic function. This is when you have a third power on your function, on your variable. So we have, I'm going to pick the same numbers, and this is, you don't have to always pick these same numbers. I'm just doing it for some symmetry, especially because we have these small little grids we're working on. So -2 quantity cubed with my parentheses. When I plug in my -2, that would be -2 times itself 3 times, and would become -8. -1 cubed, or to the third power, is -1. 0 cubed is 0, 1 cubed is 1, and 2 cubed is 8. 2 times 2 times 2. So let's plot those points. -2, and then go up 1, 2, 3, 4, 5, 6, 7, 8. We're actually off our coordinate system just a little bit, but that's okay. It's still there, it's just not quite in the picture. -1. Oh, sorry, that should have been -8. I went up instead of down. 1, 2, 3, 4, 5, 6, 7, -8. Okay, that one's not there. -1, comma, -1, 0, 0, 1, 1, and then 2, comma, +8. And so this graph, I like to call this one the river shape, because it does like this squiggly river type shape. Okay, and so this is our cubic function. Again, this one has the same domain as all the rest so far. You can plug in any number you want for x. You will get a real number out when you cube that number. And then notice what the graph is doing. We can get negative numbers, we can get positive numbers. It goes from negative infinity all the way up to positive infinity. So all real numbers will come out of this function. And then just like the last two examples, and it's a coincidence, it's not always going to be like this, but for these basic functions it does happen quite a bit, where the x and y intercept are both the same point, 0, 0. Alright, so let's go to the next page and do some more. Square root function. So f of x equals square root x. This time I'm going to pick different x values because I'm thinking about what this function is requiring. It requires I know the square root of my x values. So I'm going to pick numbers we do know the square root of. So I'm going to start with 0, because square root of 0 is 0. Then let's go to 1. Square root of 1 is 1, because this is asking what number squared makes this value, so square root 1 is 1. Let's next jump to 4, because what number squared makes 4, or what's the square root of 4? So square root of 4 is 2. Then the next value that I know is actually going to be 9, because square root of 9, what number squared makes 9, is 3. And then the next one we would actually know without the calculator would be 16, because square root 16 is 4. So notice I actually didn't pick any negative numbers this time, and that's because if I had, square root of a negative is actually imaginary. It's not a real number, so I couldn't get a real number out and I couldn't graph it. So let's graph our points we did find. 0, 0, 1, 1, 4, 2, 1, 2, 3, 4, 2, and then I can't go very far out. Let's go to 9, 4, 5, 6, 7, 8, 9 way off to the side here, 3, and the next point is too far over, so I'm not going to be able to draw that. But then this graph, I like to call this one the shooting star. It kind of shoots out like this. And so this is our starting point. We don't have anything to the left of this or lower, because 0 is the first number we can plug into this square root. So the domain this time is different. 0 is the first x number we can plug in, and then anything after that is fine. We can plug in huge numbers all the way up to infinity. And then we can actually equal 0. There is a point there, 0, 0. And then remember, we don't equal the infinities. Then the range, the output for this function, every number we get out of a square root, it's going to be positive. So notice the graph is only going up. It's starting at 0 and going up. And so the range is from 0, so 0 for the y, and then up toward infinity for the y values. And then again a bracket there because we can equal that point. And then 0, 0 is our only intercept on that one. Okay. Next is our cube root function. So notice the little 3 right here. This is called an index. And so the cube root is asking what number cubed makes the inside number. And so I'm going to pick these numbers very strategically. It is from the opposite of the cubic function that we looked at. -8, -1, 0, 1, and 8. Let's start with 0. What number times itself 3 times gives us 0? Well, it is 0. Let's go to 1. What number times itself 3 times is 1? Well, the number is 1 that does that. Let's go to +8. What number times itself 3 times gives us +8? Well, that number is 2. So cube root of 8 is 2. And then if we go to the negatives, cube root of -1, well, -1 times itself 3 times is -1. And then cube root of -8, -2, because -2 cubed is -8. And so our x values, let's plot these. So -8, so 4, 5, 6, 7, 8 off to the side here. -8, -2, so down here. Next is -1, -1, 0, 0, 1, +1, and then we're going to go all the way over to 8 was about here, and then up 2, so 8, 2. And this one is also like a river function, just sideways. Okay, so our cubic function was a river looking like it's going from down to up. This one looks like it's going from left to right, so a little bit more rounded there. Our river function sideways. So that's our cube root function. Notice it covers all the x values. It's going all the way from -infinity to +infinity on the x-axis. And even though it doesn't look like it's going up very much or down very much, it is eventually going to go all the way down to -infinity and up to +infinity. So the y values are also, for the range, is all real numbers. And then we still have 0, 0 is our only intercept. We touched the y and the x-axis there. Alright, next is our reciprocal function, 1 over x. And so I'm just going to pick -2, -1, 0, 1, and 2, and then plug those in our denominator. So this is -1/2. Then -1, or 1 over -1 is just -1. 1 over 0, let's leave that one off for a second. 1 over 1 is 1. 1 over 2 is 2. Okay, so 1 over 0 is actually considered undefined. You cannot divide by 0. And but we have to kind of figure out what happens around that. So let's plot our points so far and see what happens. So negative 2, we only go down a tiny bit to negative a half. It's not very low right there. Negative 1, we go down a little lower to negative 1. 0 is undefined when we plug that in. 1 comma 1, oh, sorry, I wrote 2 here. This should have said 1/2. So 1 comma 1, and then 2 comma 1/2, it's a little lower. So this is kind of strange. If you've never seen this before, you might not know how in the world we're going to connect these points. So I do want to give you a couple more points so you can see what's going to happen. Let's go a little wider here. Let's go to, let's see, we'll go 4 here. So that's going to be 1/4. So when I plug in 4, it's even lower, even closer to the x-axis. And then let me plug in something closer to 0. I'm going to plug in 1/4. Okay, so just adding a couple more points to this table here. When I plug in 1/4, and notice where it's going in the denominator. So this is 1 divided by 1/4. So 1 over 1/4, you flip and multiply, you actually would get out 4. So right here, here's 1. 1/4 is like right here. And if I plug that in, I get out positive 4. So what's happening with this graph is it's actually shooting up like that and then coming down toward the x-axis. And then over here on the other side, it's going down, shooting down toward negative infinity and going over here toward the x-axis. And so this is an interesting function, this reciprocal function. So we can plug in any x values except 0 caused a problem. So the way we write that is anything from negative infinity until 0. And then put our union symbol, and I'm going to run out of room, so I'll just put it underneath. And then anything from 0 to infinity. Okay, we can't equal 0, so notice I use parentheses instead of brackets. And then the range, the outputs, are actually the same thing as the domain in terms of how we're going to write it, because if you look at your graph, you have blue graph everywhere starting from like 0 all the way up to infinity, and then blue graph here at 0 going down to negative infinity, but there's no points actually touching when y is 0. So our range actually looks identical to our domain, but it's the y values. Remember, the range is the y values. And then our intercepts, there are none because we never touch either axis. Alright, the last one for this page, absolute value function. When you see those vertical bars, it means absolute value. It just means distance, technically distance from 0. So I'm just going to pick -2, -1, 0, 1, 2. And so absolute value turns what's inside of the bars positive, or asks you what's the distance from this number to 0. The distance from -2 to 0 is 2 units away. So it turns the -2 positive. And then absolute value of -1 turns to +1. Absolute value of 0 is still 0. Absolute value of 1 is 1, and 2 is 2. And so we plugged in -2, got out +2. Plugged in -1, got out +1, 0, 0, 1, 1, 2, 2. And this one is actually a V shape. Okay, so the absolute value function is this nice V shape. And then we can plug in anything, so the domain is all real numbers. You can plug in anything from negative infinity to infinity for x, and you will get a real number out. And then the range, notice nothing was ever negative because the bars turned it positive, the absolute value bars. And so the graph goes, the lowest point is 0 for the y values, and then it goes up. It goes up to infinity. And then we equal this point at 0, so there's a bracket there. And then our only x and y intercept is 0, 0. Okay, next page. Okay, so we're only going to do one on this last page here, and we'll save these other graphs for a future lesson. And so lastly, our exponential function, 2 to the x. We saw this one really earlier, actually, with our sequences that we were looking at. So I'm going to plug in our same values that we keep choosing, -2 until 2. And I'm going to start with 0. 2 to the 0 power, anything to the 0 power is 1, other than 0 to the 0. Every other number to the 0 power is 1. 2 to the first power is just 2, and 2 to the second power, because that's the exponent, is 4. 2 squared is 4. Okay, now 2 to the negative 1. Now, this one, you have to know about exponents. When you have a negative exponent, it's really like a message. It's saying, move the base, move my base. The base is 2, so you have to move this down to a denominator, and then the exponent becomes positive. So this is 1 over 2, so this is 1/2. And then over here, this is 2 to the negative 2, so it's saying move the base 2. And I'm going to run out of space, so let me go up here. So this is really 1 over 2 to the positive 2. When you move that base down, you take off the minus sign. That you've received the message to move the base, and now you take off the minus sign. So this is 1/4. So let's plot those points. I'm going to start with 0. 0 was comma 1. 1 comma 1. 1 comma 2. 1 comma 2. 2 comma 4. And then let's go back to -1, plug that in, and we got out 1/2, so it's a little lower. And then plugging in -2, we got out something even smaller, 1/4. And so this is an exponential function, and it starts off real slow over here on the left, and it grows and shoots up very quickly. The domain here, you can plug in anything as far as x goes, because you can plug in negative or positive exponents or 0, and you're going to get a real number out. But then the range, your graph never goes below the x-axis. It's never negative. It's also never 0. There's actually no point where you touch the x-axis. So we use a parenthesis. So there's no 0 for y. And then last, there's an y-intercept only. We never hit the x-axis. The y-intercept is 0, 1. Okay, that's it for our basic functions and their graphs.